Hello everyone. Today we shall look into the financial functions like accrued interest and accrued interest at maturity. Accrued interest function, it returns the accrued interest for a security that pays periodic interest. If we look at this accrued interest parameters, first one is issue, it is the security issue date, and the second one is the first interest, it is the security's first interest date where the interest is paid. Third one is the settlement date, where the security settlement date is declared after the issue date. Okay, the rate is the rate of interest like which is being provided. Par is the security's par value, or you could say the face value. Okay, the frequency is the number of coupon payments per year, how much it is paid. Either it is, if it is annual, the frequency is 1, if it is semi-annual, the frequency is 2, for quarterly the frequency is 4. Basis, it is the type of day count basis for usage. For example, if we notice here, we could see that basis, if it is 0, it follows this US NASD where 30 divided by 360 rule is followed. Otherwise we have other things related to actual 360, actual 365, or European basis methods. And finally we have optional thing, which is calculation method, where it is a logical value like regarding the calculation of value from where it is calculated. For example, if it is true or if it is omitted, accrued interest, it returns the total accrued interest from the issue date to the settlement. If it is false, then the accrued interest from a first interest is calculated to the settlement. Okay, this is the difference with respect to the calculate method. Okay, if we scroll down and see further things, then in DAX the days are counted from December 30, 1899, which is 0. It is considered as day 0, and similarly we have January 1, 2008 as particular 339,448 days, because it is 39448 days after December 30, 1899. This accrued interest has the formula par multiplied by rate divided by frequency multiplied by sigma 1 I is equal to 1 till NC, where NC is the normal length of in days, where the quasi coupon period within the odd period. A is the account account days, or you could say number of accrued days where the coupon period is within the odd period. And NL, you could see that it contains the fraction where it could include the data. So these are the few things where error could be created. For example, if the issue first interest or settlement date is not a valid date, error could occur. If issue is greater than settlement date, error could occur. Rate less than 0, par value less than 0, or you could say this frequency, if it is other than 1 to 4, then also error could occur. If basis is less than 0 or greater than 4, even then error could occur. This function is not supported in direct query mode when it is used in calculated columns or row level security rules. I hope the parameters, function formula and everything is understood. Now we shall get back to the Power BI and let us create a measure and check how it works. I'll create this measure, which is accrued interest. Here I'll write as accrued interest equal to accrued int. The first one is issue. Suppose that I issue on the date of 01/01/2023. Okay, and the first interest date is, suppose the interest is paid on 1st April, okay, 2023. Okay, and the settlement date, suppose we are settling on the date of June 30, I'll write 06/30/2023. I'll put a comma. Suppose the rate is 5%, I'll keep it in decimal 0.05, and the par value is 1000. Okay, and frequency, suppose it is paid semi-annually, I'll write 2. I'll put a comma. Basis by default it is 0 when, or it takes, even if we omit, it will take 0. Calculation method, it is optional. I'll keep it as true condition. Okay, I'll close the parenthesis and hit enter. I'll go to the home tab. Let us take a text card visual, and in this visual let us bring in this measure of accrued interest. Here we could see that around 24.86 is the value for the accrued interest as per the details which we have provided. You could verify even using Excel also. Those functions will be even applicable in Excel. And here we shall evaluate the same using accrued interest at maturity formula. What I'll do is I'll create another measure, okay, and I'll show you the difference between these two functions, how they are working. I'll write the measure name as accrued interest at maturity equal to accrued interest at maturity. Issue date is 01/01/2023 and maturity, let us suppose that it is June 30. Okay, I'll write 06/30/2023. I'll put a comma. Rate is 0.05. I'll put a comma. Par value is 1000 and the basis I'll take it as 0, which is the default basis method. I'll hit enter. Our measure will be created. I'll copy this. I'll bring in this accrued interest at maturity. You could see that both the values are appropriate, and we could calculate using the accrued interest at maturity because it calculates the value at maturity where we provide the end date. Okay, I hope this is understandable. If we see the formula of accrued interest at maturity, all the other things it will be same, except the formula, which you could see that it is the par value into rate multiplied by number of accrued days counted during monthly basis. For interest at maturity items, the number of days from the issued date to the maturity date is used. Okay, D is the annual year basis where it is calculated according to the formula. Rest of the things are same, and you could calculate either at maturity basis or else at the periodic interest where it is paid. I hope this is understandable. This is all for now. Thank you for watching, and we shall meet in the next video.